Okay, so after dividing polynomials, we have to learn to factor polynomials. So we should already know how to factor polynomials of the order 2, quadratics from grade 10, grade 11, in whatever method you're choosing. It could be decomposition or my much faster method, factor pairs. So in 3.6, we have to factor to any order, x to the 7, x to the 6, x to the 5, anything is factorable. Okay? It just takes time as the order increases. So I'm going to teach you something called the remainder theorem, which I touched on in previous sections. So the remainder theorem is if a polynomial function is divided by x minus a, so we take a line, or whatever it is, and we divide it, the remainder is equal to that function at that a value. So I said, like, instead of looking for the remainder, you can just plug in the factor into the equation. And this is what factor theorem is. If the remainder is 0, so if I use the remainder theorem and the remainder is 0, then x minus a is a factor. So we use both at the same time because remainder theorem tells us if we plug something in, we get the remainder. And then we know if the remainder is 0, it's a factor. So we use both at the same time to find factors. And yes, it is going to be plugging and chugging. So here's a very common question. Determine the remainder when x3 blah 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 is divided by x plus 7. So the first thing a lot of guys are going to do on their quiz or their homework is do this. They're going to put negative 7 here, and they're going to use synthetic division. And then you bring the 1 down, this, and synthetic division. You're going to say, oh, the remainder is negative 19. Okay, I hope I did that right quickly. But that's a waste of time. I mean, it actually took very little time. Depends how quickly you can add and multiply. But this means that the remainder should be f at negative 7. So if I plug in negative 7 into my calculator, if I can do this quickly, using my answer button, if you guys know what that means, I'm going to get negative 19. Good. So I'm right. So I don't have to do division to find the remainder. I can just plug this number into the function and it's going to tell me the remainder. Now, again, this is very useful because if for some reason I get 0 here, oh, sir, how do I get 0 here? Yeah, we're going to have to try some numbers. As soon as I get 0, I'm going to know that this is a factor. And let's take a look at this division statement that I said is super important. Why it's important to understand the remainder theorem. If my remainder is 0, this piece of this entire equation is gone. This piece. And I'm left with factored form, something times something. So it tells us right here that if the remainder is 0, it's a factor, because I'm in factored form. Okay? I don't want this because this is plus. If this was a number, this was a number, and this was a number, I can't plug in a number to get a 0 here because this is going to still be there and not give me a 0. Okay? So we need this to be gone. So if I have to factor this for the first time, I'm going to be factoring x to the 3 completely. My advice is always to use the factors of the last number to start. And it's going to take a while if you don't know how to use your calculator well and quickly. So what numbers am I going to plug in? Plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, plus and minus 8, plus and minus 12, plus and minus 24. Those are the numbers I'm going to plug in. Now, most of the time, I'm not really going to get further than like 1, 2, 3, or 4. Most of the time. There are some very difficult questions that sometimes these don't even work, so we have to use other strategies. But I'm going to get my calculator, and I'm going to use my answer button. I'll explain that after the video. I'm going to go answer to the 3 minus 5 answer squared minus 2 answer plus 24, hit equals. And then I'm going to set my answer to 1. 1 equals up equals, that's 18. Negative 1 equals up equals, that's 20. 2 equals up equals, that's 8. Negative 2 equals up equals. See how quickly I'm doing them? So negative 2 worked, I got 0. So I'm just going to write down over here that f at negative 2 equals 0, because that's big. Okay, so in that jargon that I was just talking about, up equals, blah, 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 I just did 4 plugins. That's how quickly I did it on my calculator. As soon as you find one that's 0, write it down, because it's very important. Now I have to use that negative 2 with synthetic division. Bring it down, multiply, add, multiply, add, multiply, add. If you did this, and by plugging it in, you're not getting 0, something is wrong, because this tells us the remainder theorem. is 0 if I plug in a -2. So this has to be 0. And what I'm left with here, I bring down this factor. This is an x plus 1. Sorry, x plus 2. And I bring down this. This is x squared minus 7x plus 12. Okay, remember, there's two ways you can know which variable goes where. Either because you're dividing an x3 by a linear, you're going to get x squared to start, or start at the end and it's always remainder number x, x squared, x3, x, it just, the x's climb from the remainder. Now you're here, whatever method you want to factor this is up to you. 1, 12, 2, 6, 3, 4. I know it's a 3 and a 4 to get me 7 in the middle. The signs are the same and they're both negative. That's an easy one. X plus 2, then I'm going to have 2 brackets here. X, x, 3, 4. Signs are the same, both negative, fully factored. Okay, if I wanted to graph this, no problem. I know it's the order 3. It looks like this. I know these are 3 factors. That's all I need to know. I don't need to know anything else. So here we're going to sketch a graph for a order 4. Okay, sometimes I'll throw in a 4, but it's not really a 4. Okay, and you know it's not a 4. It is a 4, but I mean it's not going to be a factorable 4. This is a 3 because there's an x in common that I can remove. There's also a 2 in common that I can remove. So why would I use 4s and 6s when I can use 2s and 3s? So my first step is going to be to factor out that 2x. This already tells me that one of my factors is 0. I already know that this is going through the origin right away. Now I have no idea what's in here, so I have to use remainder theorem, factor theorem, synthetic division, and keep going with that. So luckily, that's not a 24. This is just a 2. So I'm only going to use possibly 4 numbers, but I'll probably get it earlier than that. 2 answer cubed plus 3 answer squared minus 3 answer minus 2 equals 1 equals up equals done. F at 1. So I'm going to write down f at 1 equals 0. Again, right away, this tells me this. I already know that. I already have 2x intercepts. To find the rest, I have to use what I found in my remainder theorem and do some synthetic division. Okay, I'm only doing synthetic division with this. I don't really care about this. This is done. It's factored. It's out. So I'm going to use a 2, a 3, a -3, and -2. Bring it down, multiply, add, multiply, add, multiply, add, check. I did my addition and multiplication correctly. I got a 0. I can move on with confidence. I'm going to bring down, this is an important part, this is still a factor. Sometimes we just continue with this and we forget that that 1 is still there. That's why I graphed it early, because it's common that you forget. So this has to come down. This is an x minus 1. If the factor's a 1, it's got to be x minus 1. And this is 2x squared plus 5x plus 2. Okay? And also don't forget your 2x. I can bring that down here too. I like to have everything in every line, even though I can conclude with everything. But if you forget in that conclusion, you might lose a mark. We've got to factor this now, a 1 and a 2 and a 1 and a 2. 4 and a 1 give me that 5 in the middle. So I'm going to break this down into 2 brackets. Okay, I'm breaking down this quadratic into 2 brackets using a x and a 2x. The 2 is paired with the 2 on the inside and the 1 with the 1 on the outside. The signs are the same, they're both positive. That's too easy. That's amazing. And now I have to graph these, a -2 and a -1/2. 1, 2, 3, 4. That's the order 4. I'm good. It's a positive leading coefficient, so I know the function looks like this. So from one end, I know it's going up. From the other end, I know it's going up. There's no bouncing on the x-intercepts because there's no squares or cubes here or anything like that. They're just straight go through the intercepts. So I just kind of make up the rest. Like this. There we go. Right? I don't know where this point is. If I really wanted to, I can plug in -1 into the function and use my calculator. My calculator still has that function in it. I did not push on my calculator because then I have to type that function again. It's still there. So take 1 second to find out more points. I can just say -1 equals up equals. I know it's 2. So I know up here That's wrong. Now I gotta test it. 4, answer to the 4, plus 6. Oh, I know what the problem is. It's a -2, actually, because I used this function and I didn't plug in the -1 into here, which would multiply my answer by -2. Or so it would be like -4 or something. Okay, we're good. Okay, but just to show you the efficiency of not pushing on, it was still ready to go to plug in a function. I just have to include that 2x. Okay, so you have to sketch a graph. You can't do it from standard formula. Let's use a table of values. Disgusting. We don't want to do that. So I see if I can common factor first, always, every single time for the rest of my life. You see that first. Okay, if you don't, you're just going to do more work. So I take out that common factor. I have an order 3. I can't factor it like a quadratic, so I have to use factor theorem. I plug in the factors of this last number into the entire function until I get a 0. As soon as I get a 0, I use what I plugged in with synthetic division, and I break it down. I take what's left, I look, oh, it's a quadratic now. I'm going to use a different strategy to factor. This does not mean you can't use factor theorem here. You can still use a 1 and a 2 and plug them in. You can still do that. Unfortunately, though, with quadratics, sometimes we get fractions. Sometimes we get and this is -1/2. It's difficult for you to understand to plug in -1/2 into factor theorem. So we try to get all the integers out of the way, and we save all the fractions, which are difficult for other skills that we have to factor in quadratics. But you can still use factor theorem. Okay, next two questions. We're just going to factor another order 4. Again, I have a common factor here, which is an x, so I'm going to take that x out. I'm going to factor out an x. I'm going to get x3 minus 6x squared plus 2x minus 12. Now I'm going to plug in 1, -1, 2, 3, 4, 6, 12. And these are all plus minus, guys. These are all plus minus. I just don't like writing the plus minus signs because it's messy. It takes time. I don't need them. I just know what they are. So I get my trusty calculator. I go answer to the 4 minus 6 answer to the 3 plus 2 answer squared minus 12 answer. Okay, now I'm ready to plug in. I pushed equals. I'm going to plug in 1 equals up equals -15. -1 equals up equals 21. 2 equals up equals -48. -2 equals up equals 96. 3 equals up equals -3 equals up equals. Now I'm bothered. Maybe I did something wrong. Nope. 4 equals up equals -4 equals up equals. Very rare that you go. Oh, 6 worked. Wow. I was a little nervous. I'm like, this is not going to work. I have to go to 6. Don't lose faith. You'll get there. Okay, so I have to plug in 1, 2, 3, 4, 5, 6, 7, 8. It worked on the 9th plug-in. I just plugged in 9 terms into there in that much time. So I know 6 works, so I'm going to use 6 with synthetic division and there. -6 to -12. Do synthetic. 1, 6, 0, 0, 2. That's wrong. Oh, 12. 0. Take a look at this. We're seeing it for the first time. A 0. So I need an x. I need my x minus 6. And I'm going to use my x squared minus plus 2. Sorry. These are my factors. Doesn't say to graph it, but if I wanted to graph it, you know, it's going through 0. It's going through +6. It's an even function. I don't know what's happening over here, but I'll explain this. This is not factorable, so don't try. Okay? If it was a -2, then it's factorable. It's plus or minus √2. But it's very easy to see that this is not factorable algebraically. No zeros, no solutions. Or you can think of this, think of math like visually, like this is just a parabola shifted up 2. There's a 0 at the vertex on a regular parabola. If it's shifted up 2, there's obviously no more x-intercepts. Okay, so there's no solutions here. These are my only zeros, and this is my order. So this is happening, and something is happening there that I'm not sure about. All I'm sure about is it's not crossing the x-axis anymore, because this tells me that. Okay, so how this looks over here, yeah, maybe you want to plug in a 3, right? You already did, actually. So maybe you want to anchor some points, because there's a big distance between 0 and 6. What's it take to plug in 2 points? 7 seconds, worth it. Done. I factored it. This is factored form. Let me just conclude here. Done. Next, thinking questions, application questions. You're going to have to solve for unknown variables. And if you have 2 unknown variables, the question's more than likely going to give you 2 pieces of information to unlock this question. So if I have 2x cubed minus mx plus nx minus 2, if I know that this is divided by x minus 1 and I get the remainder, I know that if I plug in a -1, I'm going to get a -12. So I'm going to make a statement here with that key. This is the key. F -1 equals -12. That's a big statement that I got from that question. Also, x minus 2 is a factor. Oh, I know factor theorem. I know that if I plug in a 2, it's 0 because it's a factor. So I use remainder theorem and factor theorem in that question to come up with 2 equations. And these equations can now be created by saying, well, if I plug in a -1, I'm going to get, let's take a look. I'm plugging in a -1 into x, and I'm getting -12. Is this a square, by the way? Does anyone know that? I gotta check that before I make a mistake for no reason. If someone figures it out first, holler.
What is square?
The mx. It is, yes. Make that adjustment. All right, I needed like one of every order, or else I can combine or factor it. Okay, so this is a square. Now, I can't really do anything here, but I can simplify this as much as possible. So I'm going to go -12 equals, this is a -2, this is a -m, that's a -n, and that's a -2. I'm going to bring everything over to one side if you want. I'll bring maybe the numbers to this side. So this is a -4, so +4. And this is as far as I can go, because I have 2 unknown variables. It's as far as I can go. Okay, just so you know what I did, I just used the -1, bedmasked it, collected my -2 and -2 to a -4. If I bring it over this side, it's a +4. -12 plus 4 is -8. And just, you know, I can change this actually to, it's silly that I wouldn't. I'm just going to multiply by a -1 to get rid of those negative signs that are not needed. This statement is kind of the same thing. Well, it's saying if I plug in a +2 into this, if I plug in a 2, my answer is going to be 0. So I do the exact same thing now. This is an 8, so a 16. That's a 4, so 4m. That's a 2n, 2, and that's a 0. I'm going to take my 14 and call it -14 on this side. -4m plus 2n. They're all even. There's 2 negatives versus 2 positives, so I'm going to multiply or divide through by -2. So I'm going to get 7, 2, and this. Okay, remember, you can do whatever you want to an equation. You don't have to do that. You can just leave it like this if you want, if you don't see that. But I'm going to divide by 2 to lower the numbers. And if I have 2 terms out of 3 that are negative, it's worth it to multiply by a negative to have the majority positive. So that's all I did. Divide by 2, multiply by -1. There I am. I have 2 equations with 2 unknowns. You got it. Substitution or elimination to solve for the 2 unknowns. I have to find the point of intersection here. Okay, so how you want to set them up is up to you. I'll go in the middle here and I'll do some elimination. 7 equals 2m minus n, and 8 equals m plus n. For elimination, you need 2 of the coefficients to be the same. So if I didn't do that, I wouldn't have the coefficient being the same. So, you know, I went to the lowest term, and it made it easy for me. If these coefficients are the same, I have to eliminate them by adding, because that's how I eliminate. So I'm going to add these 2 equations together, and I'm going to get 15 equals 3m plus 0. And right away, I know m is 3. Okay, recall that elimination step. Go watch my grade 10 academic video on elimination. Mistake, Nick?
I think it's 5.
5, thank you. If I know m, it's very easy to figure out n. I can pick an equation that's easy right here. So I'm going to use this equation, and I'm going to say 8 equals 5 plus n. Bring the 5 over. 3 is n. Therefore, m is 5, n is 3, and I'm done. Okay, so we have to use these two keys, probably the hardest part. The rest is not grade 12 math, really. Plug them in. Use BEDMAS, simplify as much as you can. It is calculator work, but don't forget, like negative to the cube has to be negative, so it should be pretty easy. You're not going to really be plugging in like a 7 into this, right? They're usually small numbers on purpose, so you can kind of fly through them. I've simplified 2 equations with 2 unknowns, so I can either solve for one variable and substitute, okay, which is something that we usually remember more, but when I have a coefficient that's the same as another equation, I can set them up like this and just either add or subtract to eliminate that variable, and it's much, much faster. Okay, and that's it for factoring polynomials.